In section 2.5, our goal is to find the zeros of polynomial functions. We will do this using the fundamental theorem of algebra. That'll tell us the number of zeros that are in a polynomial function. We're going to use conjugate pairs to help us find complex zeros, which is why we needed to work with complex numbers in the last section. And then lastly, we're going to find zeros of polynomials by factoring. You've got your suggested problems to be working on. In order to find the zero of a function, we need to make sure that we set the function equal to 0 and solve for x. We've learned that at most we can have n real zeros in an answer. We learned that when we were working on graphing our functions. However, when we're going through and finding zeros of a polynomial function, if there aren't exactly n being the degree of the polynomial, zeros in the function, then that means that there are some complex zeros in the function. Let's take a look at a solution where we already know the zeros of the function and show that they match the polynomial degree. So again, in order to find the zeros of a function, you first set the function equal to 0. So we'll set f of x equal to 0. And then we will solve this for the value of x that makes this a true statement. Subtracting 4 from both sides, we end up then getting that negative 4 is equal to x. We found one real zero for this function. This function also happens to have a degree of n equals 1. There's an unassumed 1 on the top of that x for our function f of x equals x plus 4. This means that we should find only one answer for the number of zeros in this problem. If we had a higher degree and we only found one solution like we did here, then the other solutions that we would have would be complex solutions.